Hello and welcome to your channel Excel. Energy generation is the main difference between developed and developing countries. They produce and consume a lot of energy, and we as a developing country cannot be left behind. In order to be there, we are leaving a lot of carbon footprints. While some will argue that we can do it sustainably by using solar, wind, etc. But we can do it in a more efficient way. So today we will know a very interesting way to do that. Project Miniature Sun, formerly known as International Thermonuclear Experimental Reactor Project. While it is an experimental project, it can change the world drastically, as we are trying to harness the energy in the same way like what happens in the sun. But before I begin, please subscribe to the channel and help us spread the knowledge. But before knowing ITER, we will know why it is important and how will it change the world. And to do that, we will have to understand what is nuclear energy, what is nuclear fission, what is nuclear fusion. But what actually is nuclear? Nuclear means in our context something related to the nucleus of an atom. So what is nuclear energy? It is the energy in the nucleus or the core of an atom. Atom is the tiniest unit of matter, from me and you to the biggest of the universe. Atom has protons, electrons and neutrons. From the figure, we can see that electrons are negatively charged revolving around positively charged nucleus. Although nucleus consists of protons and neutrons are neutral particle, and hence charge in the nucleus is the charge of protons, which is positive. Number of protons and electrons are always equal in an atom, but it is not necessary that protons and neutrons be equal. When the number of protons and neutrons are equal, we refer to it as stable atom. The number of protons and the number of neutrons forms the atomic mass of an atom, which is denoted by symbol A. The number of protons, on the other hand, forms the atomic number of an atom, which is denoted by Z. The reason why we are knowing these things is that it will help us understand the fuel of nuclear energy production, as energy is produced by the elements which are made up of atoms. As we have seen that when protons and neutrons are equal, we refer to it as stable atom. But what will happen if they are not equal? Have you thought about it? When the number of protons and the number of neutrons are not equal, then the atom becomes unstable. These unstable atoms are called as radioisotopes. An element having equal number of protons but different number of neutrons are termed as isotope of that element. A single element can have multiple isotopes, meaning with same number of protons, the element can have different number of neutrons. Hence, these isotopes differ in relative atomic mass but not in chemical properties, and hence form a radioactive element. The word radioactivity comes from a Latin word which is radius, which means ray, and activus, meaning activity. So, radioactivity is the process in which the unstable atom tries to become stable. Stability is what we all want to achieve in life, right? But how does an atom does it? It simply decays. Confusing, isn't it? Let me explain the process for you. In order to achieve stability, the atom emits particles which are protons, electrons, neutrons and also photons. And this emission of particle is termed as radioactive decay. Why decay? Because it is emitting something, it is losing something to become stable. This decay or emission of energy is termed as radiation. Radiation can be of two types, electromagnetic type or nuclear radiation type. Electromagnetic like radio waves, microwaves, infrared waves, UV radiations, which are more or less not very harmful to humans. We can also see that there is gamma radiation in the frequency spectrum, which is a ionizing radiation or what we know as nuclear radiation, which is very harmful. Nuclear radiation is the second type of radiation. Nuclear radiation, as it is happening because of unstable nuclei which wants to become stable and therefore releases subatomic particles from the nucleus. It was discovered in 1896 by Henry Becquerel when he realized that uranium, which has atomic number 92, can fog a piece of film while he was photographing. In this type, the atom decays into alpha, beta, gamma and neutron radiation. Alpha radiation. In alpha radiation, the atomic nucleus shoots out an alpha particle which is 2 protons and 2 neutrons. If you know basic chemistry, you might have guessed it right. This is what the nucleus of an helium atom look like. Therefore, in alpha radiation, helium atom is released but without electron, along with a stable or similar element which is known as daughter element. From the figure, you can see that unstable parent element forms a stable or daughter element with the release of an alpha particle. The alpha here, the particles here are slow moving and having high energy with lot of electric charge, and hence has high ionization density. The amazing fact about alpha radiation is that it can be stopped by a sheet of paper, as you can see this in figure. But counter to this is the loss it causes to the living entities. It is the harmfulest form of radiation. How can it be so dangerous? Even a sheet of paper can stop it. Well, this is the very reason why it is so harmful. When alpha radiation stops, it stops hard, and the energy carried by it is deposited all at once at a point or a thing, causing a lot of damage. Beta radiation. It is when the atomic nucleus shoots out electron or positron, which is the antimatter of electron. Unlike alpha radiation, which is heavy, beta radiations are light. It is a fast moving particle with electric charge. Here in the figure you can see that beta plus decay and beta minus decay. Beta particles can be stopped by a thin film of aluminium. Gamma radiations. It is when a photon escapes the nucleus of an atom. Photons are nothing but electromagnetic waves. It has high penetrating power and low ionization density. When the ionization number is same, the higher the ionization density is, the larger the biological effects are. If you are fond of comic stories and books, you might have seen that there is gamma radiation and everything changes, right? Well, those are comics and nothing on that scale can ever occur. Gamma radiations can be stopped by a thick lead film. The difference between gamma radiations and X-rays are X-rays are generated outside the nucleus and are less harmful compared to gamma radiations. Gamma radiations are emitted from the nucleus of an atom. The next type of decay is neutron decay. Neutron radiation is produced in nuclear reactors, accelerators, etc. We can stop neutron radiation by using thick concrete or water. How does radiation really harm the body? Radiation on its own isn't really harmful. We live in a radioactive world. Even humans radiate infrared radiations in the form of heat. We are exposed to radiation in our day-to-day activities like cell phones, Wi-Fi's, etc. We even consume ionizing radiation in the form of bananas. Ionizing radiation is a high energy radiation having a lot of energy. When this high energy particle hits an atom, the atom absorbs this energy, causing the weak electron to pop off. This creates a charged particle called ion. As we all know, we humans are also made up of atoms. This high energy can change the chemical property of tissue and hence DNA. DNA is double helix. When some ionizing radiation breaks the double strands of DNA, the body sometimes makes flaws while repelling it and causing sickness, radiation poisoning and even cancer. Although there is radiation, it does not mean that every radiation is harmful. It is the dosages which are harmful. But we can calculate the amount of radiation using a dosimeter. Dosimeter measures the energy of radiation the person has received, which is why it is mandatory for a person working in the nuclear field. The amount of radiation and the actual absorption are calculated in sieverts and Gray respectively. 1 sievert can cause radiation poisoning and 10 sieverts can lead to death. But we can harness this energy of atom to produce electricity. The energy in the nucleus of an atom is called as nuclear energy. It is the energy which holds the dense nucleus together and which has huge power. But why is there a need of force or energy to keep the nucleus together, and why it cannot without this force? This is because, like in magnets, like poles repel each other. Similarly, similar charges repel each other. As we know that nucleus contains positively charged particles called protons and neutron particles which is neutral, all held at one small place, which are held together by a strong force. This power can be used to produce electricity, but it must be first released from the atom. The two kinds of atomic reactions which create nuclear energy is nuclear fission and nuclear fusion. In nuclear fission, a heavy element is split to form a lighter element. In nuclear fusion, two lighter elements are merged to form a heavier element. Nuclear fission is the current way of generating electricity. The nuclear fuel used are heavy fissile actinide elements that are capable of sustaining fission. Actinide elements are a series of 15 consecutive chemical elements of periodic table of Dmitry Mendeleev, from actinium to lawrencium, 89 to 103 atomic numbers. These are significant of their radioactivity. As seen earlier in this video, radioactive elements can generate high electricity. Uranium, plutonium and thorium are nuclear fuels. Uranium and thorium are naturally occurring, while plutonium was artificially made in the year 1941. It is named after the planet Pluto. It is highly dense, having atomic number 94 and atomic mass number 238. Plutonium is extracted from the spent fuel of uranium, when uranium 235 is extracted from uranium 238. Spent fuel can be recycled, creating a fissile material like plutonium, or stored for a short or a long-term duration. Plutonium is formed in the nuclear fuel of uranium nuclear reactor by absorption of neutron. Plutonium is highly poisonous and radioactive. It decays radioactively by emitting alpha particles, helium neutrons, and when it hits the cell of the body, it causes terrific damage. Plutonium became the basis of atomic bomb Fat Man, which was dropped in 1945 on Nagasaki, Japan, which ended the World War II in 1945. Atomic bombs and nuclear bombs are weapons that use nuclear reaction as their source of energy. Dr. J. Oppenheimer is regarded as father of atomic bomb. This year, which is 2020, is the 75th year of bombing of Hiroshima and Nagasaki.
Thorium. Thorium itself is not fissile. Fissile elements, which are those which can directly take part into nuclear energy production. Counter to this are fertile elements which have to be first converted into fissile elements for electricity production. Thorium, having atomic number 90 and atomic mass number 232, is a fertile material which is converted to uranium 233, which is also artificially made just like plutonium 239 for to be used as fuel element. Uranium 233 is highly fissile material which is produced by neutron capture in nuclear reactors containing thorium.
Sand on the west coast of India, particularly Kerala, called monoxide sand, contains the deposits of thorium in the largest quantity in the world. India's three-stage nuclear policy, which was built by Homi Jahangir Baba, is based on these resources. We will talk about India's three-stage nuclear policy in another video. India at present does not have technology to convert thorium to uranium 233, which is highly fissile. Uranium. Uranium is the main fuel used in nuclear fission reactors. Uranium has atomic number 92 and named after the planet Uranus. Uranium is naturally occurring. In nature, uranium is found as uranium-238, which is 99.3%, which is fertile, and uranium-235, which is 0.7%, which is fissile and is used in nuclear reactors. But uranium-235 can be extracted from uranium-238, which is known as uranium enrichment processes. Uranium can be enriched for peaceful purposes like nuclear energy production or for creation of nuclear bombs. You might have heard in the news that USA has sanctioned Iran for enriching uranium, as uranium is alleging that Iran is enriching uranium for becoming the nuclear country. Well, there is a treaty which stops uranium enrichment for armament, known as NPT, Nuclear Proliferation Treaty. So now let us quickly understand uranium enrichment process. This is what the uranium ore looks like, consisting of 99.3% of uranium-238 and 0.7% of uranium-235, which is mined. The ore is crushed and heated to dry out the carbon content in it. This crushed ore is added water. The slurry of ore and water is bleached with sulfuric acid. This process causes the uranium atom to bond with sulfur and oxygen, forming uranium oxide, which is a liquid. Uranium is pulled out of solution using ammonia, forming a yellow cake. This is what the yellow cakes look like. Yellow cake is also called as urania. It has a pungent smell and is insoluble in water. Yellow cake uranium is turned into gas by using fluorine, resulting in uranium hexafluoride gas, which is more pure uranium. As atoms of U38 and U35 are chemically identical, so you have to separate them by some sort of process that depends upon their mass. So people use centrifuge, which is nothing but a cylindrical container rotating at a very fast speed. This is what the container looks like. As this cylinder rotates very fast, the centrifugal force acts on it, pushing the denser U-38 outward, leaving behind U-35 in the middle. This process has to be repeated multiple times in order to get uranium-235. This gas is turned into solid by adding calcium. Calcium and fluoride reacts, leaving behind only uranium oxide, which is heated to 1400 degrees Celsius to form pellets, which are then put in rods which are used in nuclear power plants. 5% of uranium is suitable for power production, while some require 20% of uranium-235. The rest 80% is what we know as spent fuel or nuclear waste, which is highly radioactive. It is known as spent because it is no longer efficient in producing electricity. Spent fuel is radioactive waste and is thermally hot. It requires remote handling and shielding. These rods are kept in water so that they are cooled for years and then placed in containers and kept in peat deep inside the earth to, to be kept untouched, as that will be always radioactive and damaging. The mishandling of the spent fuel caused the Fukushima disaster in Japan in the year 2011. This is a picture of Fukushima disaster, which is on the east coast. Now that we have obtained uranium-235, we have got the heavier atom that is split into lighter elements, which are barium and krypton, with the release of neutron and energy. When uranium-235 is hit by a slow-moving neutron, uranium-235 absorbs the neutron, making uranium-236. It splits into barium, which having atomic mass 141, and krypton with atomic mass of 92. If you are paying attention, then you might have got it. 141 and 92 add up to 233 and not 236. These excess 3 neutrons are released along with energy. These neutrons are fast and thus are slowed by moderator, which is water or heavy water D2O. Now there should be a question in your mind. Well, if not, I want you to start questioning yourself. Why, how, etc. Now the question which should arise in your mind is that why do we need to slow down the fast moving neutrons? This is because we want to start a chain reaction in order to generate electricity. Neutron emitted should hit the another U-35, starting a chain reaction which is spontaneous and continuous unless controlled. This chain reaction is controlled using controlling rods which are made up of boron or cadmium. These rods absorb the excess neutrons in the moderator, slowing down the chain reaction. This chain reaction is not checked, which can lead to disastrous situation like what happened in Chernobyl in 1986. Chernobyl is a place in Ukraine, and the disaster is referred to as biggest nuclear disaster of the world. Yes, you heard it right. It is not Hiroshima or Nagasaki, as those were nuclear attacks. Although the damage caused can never be calculable. The Chernobyl is a place where it occurred is still inhabitable because of the radiation that is there. Let us see from the map where Ukraine is. It is near the Black Sea. It was one of the few countries which was separated from the former USSR in 1991. It shares border with Hungary, Slovakia, Poland, Belarus, Russia. The disaster took place on 26 April 1986 during a test in order to check the emergency functions and to make sure that they are working properly or not. Where the nuclear chain reaction got out of control, causing huge damage to life and property. As I said, start questioning yourself. So have you thought that how do we determine the reaction is controlled or not? It is determined by multiplication factor K. It's the number of neutrons in one generation to the number of neutrons in the preceding generation. If K is greater than 1, then chain reaction is supercritical and neutron population will grow exponentially, and hence control rods are inserted. If K less than 1, the chain reaction is subcritical and the neutron population will decrease exponentially and control rods needs to be lifted. If K equals to 1, chain reaction is critical and the neutron population will remain constant. But what does critical really mean? It is the minimum mass required to reach the sustained reaction going. Sustained reaction is on average each fusion reaction triggers exactly one new fission reaction. So the fission reaction happening in each time unit is same. So adding more material will make the mass supercritical. Supercriticality happens when the mass is higher than the critical mass. Reaction becomes uncontrollable and the fissile material will explode. Criticality of mass depends upon the density of the material used, the shape, the enrichment of the material, the purity and the temperature of the material, the cross section of the fissile material as well as the surroundings. So according to Albert Einstein, E equals to mc square, where E is energy, m is mass and c is the speed of light, which is constant. So a slight change in mass can result into large change in energy. So as you have seen, when neutron hits U35, U35 absorbs the neutron, it becomes U36 and splits into barium 141 and krypton 92, their atomic masses respectively, forming a mass of 233. So therefore the masses going in and out is not the same and hence heat is generated. This heat heats the water in the heat exchanger and steam is generated, which in turn rotates the turbine and electricity is generated. Now let us quickly revise what we have studied till this point before moving further. So we've studied what is nuclear energy, what is atomic mass, what is atomic number, what is stable and unstable atom. We've studied radiation, electromagnetic and nuclear radiation type. We've studied radiation decay, alpha, beta, gamma and neutron. We have seen nuclear fission fuels like uranium, thorium, plutonium. We have also seen uranium enrichment process. We have studied chain reaction and how electricity is produced by it. So I was trying to complete the video in one itself, but the video had already gotten lengthy. So I'll be covering the nuclear fusion and ITER in the next part. Please be in touch and watch the next part. Thanks for watching. Don't forget to share and subscribe. Thank you and stay blessed.